In this video, we're going to look at how to find the tangent and normal equations. So just recall what is a tangent equation. Imagine you have the original graph and we're going to call that f(x). Okay, now if you want to find the tangent passing a point, so let's say you have a point here. Let's call this point A at x equal A, y will be f of A. So you're going to draw a line that touching the curve at this point, and that point we call a tangent line, right? So the first step to find the tangent line, and as you know, the tangent line y equal mx plus c. So what we do first is we're going to find the gradient by derivative, and then we sub x into the derivative. That's going to give us the gradient of the tangent. The second step is we're going to find the c value, and to find the c value, we can substitute a point in, and they usually give you a point or they give you the x value, you can sub it back into the original equation to get the y value. And eventually you have a point. So you can use y equal mx plus c. You can solve for c. And finally, you have the tangent equation. So here I'm going to go over example of how to do it. Find the equation of the tangent line with this is the original curve and the tangent is at the point x equal 4. So think about you have a curve, something like that. I don't know how this one look like, but at x equal 4 here, you want to find the tangent line. That's our question, all right? So my first step is I'm going to find the gradient first, and to find the gradient, I'm going to find the derivative of this equation. So y equal x to the power 3 over 2 minus 4 x to the power a half. Now we're going to find the derivative. And if you recall how to find the derivative x to the power 3 and 2, derivative x to the power of n will be n times x to the power of n minus 1. So x to the power of 3 on 2, you bring 3 on 2 to the front, and then you do 3 on 2 times x to the power of 3 over 2 minus 1, which 3 over 2 minus 1, which you can write that as 1 half. Okay. And then you're done with this one. Now you do the second term, which is minus 4 times, and then the derivative of x to the power 1 half, you use the same formula. So you bring n to the front, n is 1 half, times by x to the power of 1 half minus 1, which is negative 1 half, like that. Then all you do here, just simplify a little bit. 3 on 2 x to the power of a half, I can write it nicer 3 over 2, and then x to the power of a half, I can make that as square root of x if I want to convert to zero form. 4 times a half give me 2, and then x to the power of negative a half, I can make that to the bottom become positive, and then make it positive a half, x to the power of a half here, and x to the power of a half, you can write that as square root of x, right? Now they give me the point is x equal 4. So what I do is I substitute x equal 4 in. So at x equal 4, I substitute into the derivative. That will give me the gradient of the tangent. So mt equal 3 root 4 over 2 minus 2 on root 4, sorry. So root of 4 equal 2, 3 times 2 is 6, 6 divided by 2 is 3, and then root of 4 equal 2, 2 minus 2 is 1, 2 divided by 2 is 1, and 3 minus 1 equal 2. Now you're done with this step, so you can find the gradient equal 2, all right? Your next step is you need to know the C value, the one, the set. So to do that, they give you the point, they give you x equal 4. You can substitute back in to find the y, and eventually you get the point, and then you can solve the C. So I have x equal 4, and I'm going to substitute into the original here. So I have y equal 4 to the power of 3 over 2 minus 4 to the power 4 times 4 to the power of half. Okay. Then what is 4 to the power of 3 on 2? 4 is 2 squared, and then to the power of 3 over 2, like that. So you can see index law, 2 times 3 on 2. So technically the number 2 here, you can cancel the math. So you're left with 2 to the power of 3, and 2 to the power of 3 is 8. Minus 4 times 4 to the power of a half, you do the same thing, is 2 squared, and then to the power of a half. So the 2 and the 2 here we cancel out. So 4 times 2 is 8. So 8 minus 8 equals 0. So you get the point. The point will be 4 comma 0, right? And then once you've done that, you can find the C value. So y equal mx plus c, and I know m is 2, and I know the point, so I sub in. So I have y is 0 and x is 4. So 0 equal m, I just got m from this step, m equal 2 times 4 plus c. 2 times 4 is 8, so negative 8 equals c. There you go. So the tangent equation that you will have is y equal 2x minus 8. Okay. We're going to do another example here. This time we're going to do with the circular function. So let's get started on this one. Finding the equation of a tangent of the curve, and it's past the point x equal pi over 3. So we basically follow the same step. Step 1 is you're going to derive it first. dy on dx equal derivative of sine is cos, so cos of x, right? Then they give you the point pi on 3, so you sub that in. So at x equal pi on 3, you sub that in, so derivative or the gradient equal cos of pi on 3, and cos of pi on 3 is cos of 60 degrees, which is 1/2. Then you're done. So you get m equal 1/2. Step 1 done. Now step 2 is we need to know a point. So to know a point, we're going to sub x equal pi on 3 into the original to find y. Okay, we want a point. So we have y equals sine of pi over 3. And sine of pi over 3 is root 3 over 2. So by step 2, we can see that we have a point here. That point is when x equals pi on 3, y is root 3 over 2, like that. Okay. Then your next step is you're going to find the c value. The tangent equation is y equal mx plus c, and you know a point and you know the gradient. You can just have it in solve for c. So x, y, and I have the gradient here. So I'm going to substitute y as root 3 over 2 equal m is the gradient, which is 1/2, right? Times x is pi on 3 plus c. So a half times pi on 3 is pi over 6 plus c, and I have equal root 3 over 2 here. Then I can solve for c by taking away pi over 6 over root 3 over 2 minus pi on 6 equals c. So therefore, the final answer will be y equal. So when you write the answer, you would have y equal, the gradient is a half, so a half of x plus c, c is a whole bunch of fraction here, root 3 over 2 minus pi over 6. Okay. All right, now we're going to move on to how to find a normal equation. So what is a normal equation? A normal line is a line that's perpendicular to the tangent. So think about when you have a graph, something like that. This is a parabola, but yeah, just do it here. This the example is a pretty big one. All right, but it could be any curve. So think about you have an original graph and equation really. Now you have a point. At the point here is, let's call this point A, f of A. Okay. If you draw a line that touching the curve, and we discussed that dark line is called tangent line. So a normal line is a line that's perpendicular to the tangent. So at that point, the point on the curve. So from here, you're going to make 90 degrees. So it's going to look like that. And it's make it 90 degree here. So this line we call a normal line. So a normal line and the tangent line, they're perpendicular to each other. Because they're perpendicular, what happens is to their gradient is the gradient of the normal times the gradient of the tangent. They have to be equal -1. So you time them together and equal -1. Or you can write the gradient of the normal, mn, n stands for normal, equal -1 if you divide over -1 over m of tangent, which is mt. Okay, so mn equal -1 over mt. So how do we go about finding a normal equations based on this concept? So your first step is just like a tangent, you would need to find the gradient first. And to find the gradient, you're going to derive the equation to get the gradient of the tangent. And from the gradient of the tangent, you can get the gradient of the normal by negative reciprocal. So my first step is I'm going to derive it first. So to derive this, which is 3x squared minus 4x. Okay, x3 is 3x squared, 2x squared, 4x. Then you substitute. You can see that give the point here is x equal 1, y equal -1. So x equal 1, I sub it in. So at x equal 1, when I sub in here, that gives me derivative, and derivative is the gradient of the tangent. So please remember that, not the normal. So I sub 1 in, I have 3 times 1 squared minus 4 times 1. 3 minus 4 is -1. So the gradient of the tangent is -1. Therefore, I can make a conclusion that the gradient of the normal will be -1 over the gradient of the tangent, which is -1 over -1 equal 1. So I'm done step 1. I find the gradient of the normal is 1. Okay. Then my next step is pretty much similar to the previous one. I have the point is 1 and -1. So I sub 1 and -1 into y equal mx plus c. I can solve for c. If they didn't give you the y value, then you need to sub back into the original to get the y value. Right? So y is -1 equal m is 1 times x is also 1 plus c. So -1 equal 1 plus c, c equal -2. Therefore, the normal equation will be y equal 1x, which is just x, plus c, c is -2, so x minus 2. All right, here is just one more example on the tangent and the normal. So this time we're going to combine these together. Okay, so find the equation of tangent normal of this curve and it's passed through this point. We're going to do tangent first and then we're going to do normal later. So let's do tangent. So to find the gradient of tangent, we're going to derive dy on dx. dy on dx, we derive of cos in negative side. And because you have a negative here, that's become positive side. So derivative of negative cos is positive side. Then that gives you the point x equal pound 2. So you sub that in. So at x equal pound 2, the gradient of the tangent mt will be sine of pound 2, which is 1. So mt equal 1. And then you can find the gradient of the, you can find c. So y equal ms plus c, and that gives the point here. So we're going to sub pound 2 and 0 in y equal mx plus c. So the y value is 0 equal m is 1, x plus c, we don't know c, sorry, x equal to 1 times power 2 plus c, so c will be negative power 2. So therefore, the tangent equation will be y equal 1x minus tan 2. Okay. And then now we're going to do normal this time. So to find the normal equation, we pretty much follow the same step. And we already got the tangent equation. So m of normal is negative 1 over m of tangent. And we know m of tangent in previous information, the m of tangent equal 1. So negative 1 over 1 just give you 1. All right. And then that gives the point, the normal past the same point. So power 2 comma 0, we substitute in y equal mx plus c. So the y is 0, m is 1 times, sorry, I have negative 1 here. Negative 1 on 1 is negative 1. M is negative 1 times x upon 2 plus c. So c will be pi over 2. Then you have the equation that will be, the normal equation will be y equal m is negative 1x plus pi over 2. So this is the normal equation, and this is the tangent equation.